So, welcome to the first steps with the microbit teacher training. I've put this training together to raise awareness really of the microbit. The idea is that through this training you can learn how to teach with the microbit in your classroom. It's for the complete beginner, so we'll start with the basics and we'll take you through a few lessons so that you can see how the first steps of the microbit scheme of work could easily be taught to classes in your school. And we're aiming really at year 5 and year 6. So don't worry if you've never used a microbit before, don't worry if you're a technophobe, because it's all pretty simple really. We'll start with a presentation that I would normally give when I'm doing the training live with teachers, and then I'll move you onto the actual physical bits and pieces, and we'll work through a few activities like that. Okay, thank you very much. I usually run the training to exemplify the way I would teach this topic. So when teaching to the children, I would use this slide to set the scene really, and to give them a rationale for learning about physical computing. So having read these three sort of philosophical statements, hopefully they'll work out the answer to the question at the bottom is themselves. They are going to be the people who will be building these systems. The Internet of Things is all of these physical things that are connected to the Internet. So some of them will be measuring and putting data into the Internet. Some of them will be carrying out various activities dependent on that data, or the data will be stored and used at a later date. And there are billions of these Internet of Things devices. To give them an idea what these devices are, this advert here shows a number of Hive devices that can be connected to the home, and the children may be familiar with some of these. I also tell them a story. This is the story of a man who's had a pacemaker fitted because he's got problems with his heart. The pacemaker's detected arrhythmia, and without the patient knowing it, because it's a Wi-Fi pacemaker, it sent a signal to the internet. That signal will then be used to inform the consultant of the problem, and the consultant can then make decisions based on the data received. And because it's a serious problem, an ambulance will automatically be dispatched. None of this with the patient's knowledge. GPS system in the ambulance will route the ambulance by making use of sensors along the way, and it will send the ambulance on the fastest route to the patient, and the ambulance will even cause traffic lights to turn green in its favor so it doesn't get slowed down. The GPS system will let the hospital know the expected time of arrival, and the hospital theatre team can be prepared so that they are ready for the patient as soon as the patient arrives. So all of this has happened without the patient even knowing, and it's all been set in motion by devices, physical devices connected to the internet. Now, teaching about the Internet of Things, particularly as so many of the devices are Wi-Fi connected, has been very difficult in the past. But the microbit is an Internet of Things device. It has got Wi-Fi built into it, and so you can use it as a Wi-Fi connecting device between one microbit and another, or even a microbit and the Internet. This is one of the beauties of the microbit. The rest of this training will be on the first steps with the microbit scheme of work. And there is a website that explains everything you need to know. Now, for the training, what I've done is I've created a sort of introductory page called Setting Up, and we'll have a look at that in a minute. But each of these pages is a different lesson, so you can have a look at some resources for teaching the children and the detailed lesson plans by clicking on any of these lesson pages in the website. So here's the lesson plan for lesson 1, and we'll be going through that as part of the workshop. So don't worry about making notes, and don't worry about trying to remember anything, because it's all in here. There are also some teacher's notes on this page here. So that's what we will be using for the training. We'll probably go through lesson 1, lesson 2, and maybe lesson 4. And so the rest of the training will be hands-on, and I'll refer to this first steps of the microbit scheme of work as we go. The way I run the workshops is to teach teachers in exactly the same way that I would teach children if I was teaching those particular lessons. So the workshop will start with lesson 1, we'll then do lesson 2 and probably move on to lesson 4, and by then you'll have got the idea. So the starting point is really the First Steps website, and the links to the First Steps website I've given to you if you've got the package stuff sent in advance, and that's on this piece of card here, so it's the first link there. And if you go to the First Steps website, you'll have all the background information and lesson plans. So if we're going to start with lesson 1, we click on lesson 1 there. There are some resources that will be used for teaching. These would be things that you'd put on your big screen. And also a lesson plan. So I'm going to work from the lesson plan, and lesson 1 lesson plan is the same as all the others, and they're a typical lesson plan. So there's a little bit of sort of background, then you have the learning objectives, resources you'll need, prior learning, an introduction. And this is the introduction that you would give to the children at the start of the lesson. So you can hand out microbits, etc., take them through what a microbit is and a couple of safety things and the layout, 1 or 2 details on the microbit. And then we'll be on to activity 1. So the first activity is to label up the worksheet, and they can keep that then for future reference. It's got the names of parts of the microbit on them. The second activity is to start using the Make Code editor. So you'll get the children to Google Make Code and create their first project. So what I'll do is I'll quickly jump to Google and then type in Make Code. And the first link that comes up, Microsoft Make Code for Microbit, is the one you want. Click on that, and then the children are into the editor, and what they need to do is create a new project. So they click on that big purple button, and always get them to give it a name, because when they've created 10, 20, 30 scripts, they'll get mixed up. So I'm going to call this one, as it's my first project, Project 1. Always suggest that they use a name that reminds them what the project does, and then create. And once I've created that, it moves me into the code editor screen. And this is reminiscent of Scratch. I think its design was based partly on Scratch. And so you pull out blocks and build your script here using those blocks. The one thing that Scratch doesn't have is a simulator. This is a simulator, so this is a microbit, a virtual microbit that lets the children test their code and make sure it works before they begin to download it. So coming back to lesson 1 then, we've got into the Make Code block editor, and we've seen that that's got a simulator, and we can test our code on the simulator. So then gets the children to do some experimenting. So by experimenting, the children will learn a lot and they'll enjoy the freedom to try things out. And I would give them quite a bit of time, at least 10 minutes, just to see what they could discover for themselves. And if they've done some scratch programming, they'll realise that if you click on these things here, you'll get another whole set of blocks, and you can pull them out and start doing things with them. Loops, what are loops? They may have heard of loops. Repeat 4 times. They might go into basic and realise that, they've got some pictures there, some icons. So they could try then what happens if I put that in there. And you can also explain to them that if they want to test their code, then they click on the simulator, and the simulator will have a green button. When they click on the green button, they can test their code. You can give them some simple suggestions to try. Once they've had a bit of time to experiment, satisfy their curiosity a little bit, then you can move them on to activity 3, where you give them some script and get them to hack the script. And the script that you'll give them is this script here. Okay, the DuckDuckGo script. And the best way to give them that is just to show them the script on the big screen. The script is on the lesson plan as well as on the website. I use this website as my sort of resources for showing them stuff on the screen. So you say, right, can you build this script? And the idea is that they'll go into here and they'll try and find the blocks. So you want the onStart block. We don't seem to have that block there or that block. But this repeat block, yeah, we need to use that. And that goes inside there. And we've got a show icon block, we'll need that. We need another show icon block. So on, you can work it out for yourselves. The icon we've got is a heart, and we need a duck. So if we just click on the drop down, we have actually got a duck there. But if you want to edit your icon, then you can do that by pulling out this, and you can then light up the LEDs or leave them unlit like this. And so if you put that block in there, you can see that that image, let's do something else, that image will be displayed when I click on there. Actually, the children will spend ages just playing around with that. So we want to show a duck icon, and then before we change to a different icon, we want to be able to see that, so we'll need to put in a pause, and the pause timing is in milliseconds. So if we want 1 second, we need 1,000 milliseconds. Then we change to our next one, and we want this just to be a square. I'm assuming that you've already had a play around with this and that you know how to do this. We want this block again, so I can select that block and then duplicate it rather than go into the palette and pull it out again. And the other change I need to make is the number of repeats we want. So get them to make that basic script, and you can check that they've made that and it does what it should do, which is to show a duck, wait a second, show a square, and do that once and then twice. And then get to hack it. And tell the children there's nothing wrong with hacking as long as you have the permission of the person whose code you're hacking. That's absolutely fine. So they can make various changes to see if they can get their own little animation going here. They might want to add more icons, change the number of repeats, change the icon, change the time. So give them plenty of time to play around with that particular script before you move on. The next activity, so we've done activity 3, hacking a script, and that's it really for that lesson. There's a little bit on assessment, and then a sort of summary, and then you're ready for lesson 2. Okay, so I've rushed through that, but I would spend an hour on that, give them plenty of time to play, so, you know, for their own experimentation, 10 minutes, 15 minutes. If they're enjoying it and it's productive, even longer. Hacking this script, again, give them plenty of time to hack the script. They're practicing essential skills, so it's a perfectly valid thing for you to be doing. Cut. So I'm going to take you through lesson 2 because it's an important lesson. It's where the pupils will learn how to download a script they created in the Make code editor to their microbit, so they've got a self-contained portable computer they can take away to run the app. So we're going to click on New Project. It's important to name your project with something meaningful. So this is going to keep track of the number of people in an event. So it's a sort of thing that somebody at the doorway might have, so that as people enter the event, they can press a button and it'll add 1 to the number of people entering, and as somebody leaves, they can press another button and it'll take 1 off the number of people. So we need a way of keeping track of the number of people. We need a variable. So another useful aspect of lesson 2 is that it teaches children about variables, and all the lessons in the first steps of the microbit scheme of work will teach aspects of computing and coding. So I'm going to variables now, and I've got to make a variable. It's always important to name a variable with something meaningful. This one's going to keep a track of the count of the number of people in the event, so I'm going to call it count. Now, at the beginning, I need to set that variable to 0, so I'm going to use a onStart block. In fact, I've already got an onStart block. Use an onStart block, and I'm going to set count to 0. Now, to add 1 to the count, we'd say increment the count. I'm going to click on button A. So I need an input on button A pressed. So when button A is pressed, I want to add 1 to that count variable. So if I go back to variables, I can see this. Change count by 1. That literally means add 1 to the count variable. And I want to be able to see the number of people in the event. So from basic, I can say, I don't want to show a string, that's for letters. I want to show a number. And what number do I want to show? Not 0, but the number in the count variable. So I go back to variables, and there's the count variable, so I have to put that in there. Now I want a very similar code for button B. Well, the easiest way to do that is to just select that block, duplicate it, and then edit it accordingly. So this is for button B, so I just change that to button B. And I don't want to change count by 1, I want to take 1 off the count, so I just put a minus in front of here, -1. As always, get the pupils to test their script before they download it. It's much easier to spot and debug your script before you download it, rather than download it, then having to make changes and download it again. So on the green triangle here, click on the green triangle, and I can now press button A, and I get 1. Press it again, 2, 3. So as people are going into the event, I can increment the number. Somebody leaves, I press button B, and the count goes down. Because the display is very small on the microbit, when you get to double figures, or you'll have to wait for the number to scroll. So 10, 11, 12, etc. And that's it. So that's now tested, it works, so we need to get it onto the microbit. So my people counter script is ready, and I want to download it to my microbit. The download button is down here. If I click on that, now different things will happen depending on how your computers are set up. mine by default seems to be going into, because it's a network computer, into some place. And as long as I know where it's gone, I can then find it and put it in my microbit later. What it's doing essentially is it's saving the script you've written as a hexadecimal file, a .hex file. And it's important to name it because otherwise it'll just be called Microsoft something by default. So I know that this is my people counter file, and I could either save it in a particular place, such as downloads, or I could just let it save and then find it later. So you're just going to have to experiment with that and find what works. But if I click on save now, I know that I've saved it in my downloads folder. So I'm just going to close that splash screen, and now I have to connect my microbit. In fact, I can see it down here, and if I click on the show in folder option, I should be able to see my script. Now I've got loads of microbit scripts on here, but I've got the one I want, people counter, down here. Now to get that onto my microbit, I've got to plug in my microbit, which I do using the short download cable. The small end goes into the top of the microbit. It can only go one way round, so you've just got to look at the shape and match it up. And then the USB goes into the USB port on your laptop. So now that my microbit is connected, I can go back and I can look for it. And here it is, microbit E. It's assigned at the E drive, but it's microbit. It's just like a memory stick, flash memory. It will appear there. To get my people counter script onto it is just a drag and drop. So make sure you can see your microbit and your file, and then drag and drop the file on your microbit. When that happens, the light on the back of the microbit will start to flash, and you know that your script is being copied across. Don't do anything until it stops flashing. Once it stops flashing, before you detach it, it's probably a good idea to test it. So if I press button A, I get 1, press it again, 2, 3, etc. Press button 4, OK. So that's working. I can now detach my microbit from my computer. If I now try and use it, it won't work because it was getting power from the computer. It now needs a power supply. So what I then do is attach a power supply. Now when you're doing this with your pupils, I would make sure that you've already attached the power supplies for them. Attaching is actually not the problem. The problem is detaching them, and children have a temptation to yank on the wires, and what happens then is the wires get torn out of the little plug, and that power supply is then useless. To take the power supply out, you actually have to grip the little white plug and pull it out with the little white plug. Okay, now I've got power. If I press button A, 1, 2, 3, press button B, etc. So I've now got a portable device. My microbit is clearly working as a self-contained computer using power, and I can now take this to my event and use it to count people. So in lesson 4 we get physical. One of the beauties of the microbit is that it has this row of pins along the bottom which we can use to connect components to. So in lesson 4 it explains a little bit about getting physical, using physical computing, and it also in activity 1 tells the pupils how to connect components to their microbit. If you've had the pack that I sent through, you'd have had these components and some crocodile clips. So the lesson 4 project is to make a signal light. So what I'm going to do is just take the red LED from the others. Now, one thing to know about LEDs is they have polarity. It does matter which way around you connect them. So to make things easier, we've got a red wire and a black wire. The red is positive, the black is negative. And so the red wire has to go to, we're going to use pin 0 for our signal light, so the red wire has to connect to pin 0. Now you could just sort of wind the wire around there and make a connection, but it's likely to fall off. So we use crocodile clips to make quick and simple connections. It doesn't matter which colour you use. You'll notice that the crocodile clips I've sent out are bundled together with a cable tie. This is how I hand them out to the pupils. It makes it much easier when you're collecting them in at the end to check you've got all of the crocodile clips. So 5 is enough. 5 is enough for all the projects in the microbit first step scheme of work. So I'm going to take my LED and I'm going to use the red crocodile clip because that's sort of logical. And the crocodile clip at the other end has to be connected to the microbit. I'm using pin 0, as I said. Now you could just clip the crocodile clip on like that, but they tend to fall off. The best way to do this is to connect the crocodile clip at 90 degrees and put one of the jaws of the crocodile clip through the hole. And that way you get a good secure connection. So I've put my red wire to pin 0 and the black wire has to go to the GND pin, the ground, and the earth pin, if you like, the negative side. So I'm going to use my black crocodile clip for that and connect it to the ground pin. Okay, so now my red LED is connected to the microbit, and as I previously downloaded the code, if I press button A, the LED should come on. But because we are not connected to a computer, we need to provide power. And I would have connected these before the lesson, so they're ready connected for the pupils. If we provide power, then that power will not only power the microbit, but it'll also power our signal light. Okay, I'll show you how to do the code in a minute. But there's our signal light working. Now, once you've got the idea, you could connect all sorts of different components to your microbit. So if I take those two off, I could connect a buzzer. These are old components that I had in a cupboard, and we can repurpose them for microbit work. Also, many schools have bought these kits to teach circuit electricity, and these are compatible with a microbit. So these clip circuits, if I connect my microbit to one of these components, then I can use that as my signal light. That's physical computing. Okay, lesson 4, take 6. So in lesson 4, we've made our signal light by connecting an LED to the microbit. We now need to compose our script to control it. So the script is here on lesson 4, it's also in the lesson plan. So if I go to my make code editor, I've already named it signal light, and I want my signal light to operate continuously. So the first thing I do is pull out a forever loop. Now we want our signal light to come on when button A is pressed. So we need, from our logic tab, we need this condition. If something happens, then do something else, do something else. So if the button A is pressed, then we want the signal light to come on. So from the input, I'm going to select this, button A pressed. And what we want to happen if button A is pressed is that the signal light is switched on. The signal light, if you remember, was connected to pin 0. So I need to go to the Advanced tab
and click on the pins to control pin 0. And I'm going to use digital write pin 0 to 0. What that means is turn pin 0 off. But we want it to come on when we press the button, so we just change that to 1, which means on. I want the light to stay on for a second before it automatically turns off. So I'm going to put a pause for 1,000 milliseconds or 1 second. And then I need a block that will turn pin 0 off. So I go to pins again, digital write pin 0 to 0. Now, if button A is not pressed, I want the light to be off. So what I can do is just use the pins block again and make sure that pin 0 is off. And now I can test it on the microbit. The microbit will animate the pin to show it coming on. So if I just make sure the green flag's pressed, press the red button, the signal light comes on for 1 second. Okay, my script is working, so I can download it.
In lesson 9, the project is to build a burglar alarm, and so we need inputs. So just to quickly take you through the circuit in lesson 9, the lesson is fully explained, but if I just disconnect this microbit, and I'll just show you what we've got here. So the output side is very similar to lesson 4, except in this case we're controlling a buzzer. So I've got a buzzer here, 3-volt buzzer, and that's got to be connected the right way round. So I put the red wire to positive and the black wire to negative. So that reminds me the black wire goes in ground. And this time I'm not using output pin 0, I'm using pin 2 to power the buzzer. So that will power the buzzer when my program tells it to. For input, I'm going to use pin 0, and I'm using a switch here to detect the input. So let's just move that out of the way. So here's just a standard push switch. Any switch could be used. In the kit of circuit components, you've got this switch. You could use this switch. Let's use this switch. So I'm going to connect this switch to the microbit as an input device. Now there's no polarity. It doesn't matter which way around you connect them. I'm just going to use the yellow wire with the yellow crocodile clip, and I'm going to use the green wire. The green crocodile clip to the black wire. Okay, and so for input, you have to connect it between your input pin. We're going to use pin 0 and 3 volts. And as I said, it doesn't matter which way around you do it. So I'm going to put the green one in my 3 volts and the yellow one in 0. So when I press the button, the microbit will receive an input, and as you can see, we've got a sort of an angry face here. I've got the lesson 9 program downloaded, so it says reset. So a burglar comes along, treads on a pressure pad or triggers some sort of switch, and you can see how we get the input detected. And then the output is going to be the alarm. So for the alarm circuit, as I said, I'm going to use a buzzer, and so I'm now going to just press A and B together to reset that, connect my black side, my negative side of the buzzer circuit to ground, and my red plug to pin 2. So yellow and green, just reset that. Yellow and green are for input, and red and black are for output. Okay, and then, oops, I keep pressing this button here. Let's just reset that. And you can use any component, really, with a microbit that will work with 3 volts. So if I take my push switch off and connect my green and yellow wires across this push switch. That can now become my input device. So when I press the switch, we trigger the alarm. And the children can even make their own input devices. In lesson 9, we get them to make a pressure pad with some aluminium foil and some cardboard, and if they connect that where the switch should go, so let's just take those out of the way, and we've now got a pressure pad, and that is now our input device. So when the burglar treads on the pressure pad, it triggers the alarm. So there's no need for expensive components when you're working with the microbit. Physical computing can be done with homemade components or cheap components like these. Most of these are sort of a pound on average in price, so not very expensive. And if you can find a parent who's good with a soldering iron to solder some wires on for you, that will save you some cost.
This is the make code script for lesson 9, and the input part is here. We're reading, detecting if there's an input to pin 0. So if pin 0 equals 1, in other words, the switch has closed, the burglar's trodden on the pressure pad, then we write to pin 2, which is connected to the buzzer, 1, which turns it on, and we also show an unhappy face, there's a burglar in the house. And the alarm will continue to sound until buttons A and B are pressed together. If buttons A and B are pressed together, then the digital write pin 0, that is set to 0, and the digital write pin 2 is also set to 0, and that will turn off the buzzer. And then we let the householder know that the burglar alarm has been reset by displaying the word reset. And then the whole thing can happen over and over again. So the key thing for input is this part of the script here, and that could be digital read pin 0, pin 1, pin 2, depending on which pin your sensor is connected to.
So that concludes the first steps with the microbit training, and the website has all the information you should need. So go through the website, look at the lesson plans. But if you have any queries or you find any problems with it, please do email me. My email address is on the website. It's hastklass, HASTKLASS @gmail.com. I'll be delighted to support you. Thank you very much, and goodbye.